Hi there, welcome to our next lesson in our C5 How Much Quantitative Chemistry topic. This lesson is all about titrations and how to carry out a titration effectively and why we actually need to do them. Anyway, I will see you at the end of the video and I hope you enjoy it. Bye-bye. Okay, so our objectives for today's lesson on titrations is by the end of this lesson you should know and understand how to set up the burette correctly and safely, and how to carry out the titration with precision. Now, the point of doing a titration is if you have an unknown solution and you need to try and find out what the concentration of it is. So for example, you might have a pollutant in a river sample and you need to find out how much of that pollutant is in there. A titration is a very accurate way of trying to work that out. This is all the equipment you will need to carry out a titration. You'll need to set it up as shown in a moment, but first we need a results table here. So we've got initial, final and titer value with 3 readings after the rough one. So attach your burette into a standing clamp, making sure that the tap is closed. Filter funnel to the top, ready to add your acid to the burette. When you add your acid, you need to ensure that you lift up the top of the funnel from the burette. Ensure the tap is closed. Your burette to above the 0 line and remove the funnel. Open the tap at the bottom to ensure that the bottom part of the burette has some acid in. This should also reduce the line at the top so it is below 0. You can take this value and you can record that into your results table. It doesn't matter if it goes well below 0 because you'll be able to work it out later on. Collect your sample of the unknown solution using a pipette. Remember to add the pipette filler while holding the top of the pipette. Gently press button 1 to empty the pipette filler and then press button 2 to suck up the solution. Get your head level so that you can see when the meniscus, which is the bottom of the line, is at the line that shows the 10 centimetre cubed. You can then remove the pipette filler and you can empty the pipettes.
Right, stop there.
Now you can empty the pipette and carefully add the bottom of the pipette into the solution to get the last drop out.
That'll do.
Add a couple of drops of methyl orange indicator to the unknown carbonate solution until it goes to an orange colour. Ensure that you get the full colouring by giving it a swirl. Place the conical flask under the bottom of the burette. Notice the orange colour. Start adding the acid solution to the solution of the carbonate. Remember to keep swirling so that you can see the colour change of the solution. You can see it's still remaining orange as it's still in an alkaline solution.
Right, stop.
If we see here it just being added drop at a time, you can see when the drop hits it goes to a pink colour. Now the pink colour soon fades as it is not a complete reaction. As we get closer to the end point, the colour starts to remain pink for longer, but it can fade with swirling. We know when we're at the end point because the pink colour will stay. Now it will only take 1 drop to keep that permanent colour change as pink. Have a look at the top of the burette to see how much you've added and then record that in your results table and then calculate how much you've added in total. Finished, and you've got 3 results with 2 within 0.1 you have finished. Okay, so reading a burette can be a little bit complicated. Now on here we've got our burette, and we've got a reading of 0, 1 and 2 as we go down. Now we've got intervals here, and we've got 0.0 here, 0.2, 0.4, 0.6, 0.8, and then we go up to 1. Now on your actual burette there will be further ones in between, so oh, don't want that there. So there'll be one in here, in here, in here, so you should have 10 readings in between, but I'm just going to show you how we actually read the burette from here. Now you'd expect to have a line that looks like this, when in reality the line we get is shaped like this here, and this is called a meniscus. Now with the meniscus we actually use the bottom of the meniscus as our reading line. So from here at the bottom we would read across. Okay, now when we look at the 2 lines here, it's either going to be on the line or between the line. Now if it's on the line, the value is 0. Let's say for example it's this one here, it's 0.40 if it's on the line. If it's between the line it would be 0.45. So it's either on the line or between the line, and that's what we read from our value. Okay, so when do we stop doing our titrations? Now you can see we've got a model results table here, and what we'll have is our initial reading, our final reading, and then our titer value. Now these are all measured in centimetre cubed. Okay, now the rough one, we'll put a value in here and then a value in here, and we'll be able to work out roughly where we should end. Okay, now we should be doing this roughly about a centimetre at a time. Now when we come to do run 1, we can take this value here, so let's say for example it's 15 centimetre cubed. What we can do is open it up and run in 10 to 12 centimetre cubed. Once we get to that 10 or 12, we can then just add it drop by drop until we can see that colour change that we saw earlier. Once we get that, we can then record the value in here. We can then repeat it in here until we can repeat it until we get 2 values in here, in this value here, that is between 0.1 centimetre cubed. Once we get those 2, then we get an accurate reading, and we can work out the average of the 2 values. Okay, so that concludes how we do a titration. We'll be looking a little bit more detail in that in the lesson. We'll be having a go at doing that and trying to work out an unknown concentration. Anyway, I hope you enjoyed it, and I'd also like to say thank you to Leah, as she helped me with the videoing of the experiment. Anyway, take care, and I'll see you soon. Bye bye.